Okay, so yesterday we talked about a rate of change. And remember that our formula for rate of change was y2 minus y1 over x2 minus x1. And that you had to have the y's on top and the x's on the bottom. And we talked about how rate of change is just a snapshot of any graph. It can be used at any graph. And we're looking at what's happening between these 2 points at one time. And we talked about how if it's going up, the rate of change is positive, going down, it's negative, horizontal, you have a 0 rate of change. And that the steeper your line segment is, or your curve is, or whatever it is you're looking at, the greater the rate of change is. So today we're going to talk about something called slope. Slope is a new vocabulary word. Slope is a constant rate of change. And what this means is slope is when the rate of change is going to be the same on the entire graph, no matter which 2 points you pick. If you remember on that population graph, we talked about how if I assigned every student in the room a different set of points, each of them would come up with a different rate of change. You may either have positive, negative, 0. You could have very large numbers or very small numbers. But if you're going to find a slope, that means you have a constant rate of change, which means it doesn't matter which 2 points you pick. I could assign everybody in the classroom a different set of points and everybody will come up with the same rate of change. When that happens, you have what we call a slope. And this slope is only going to apply to a graph that will constantly increase and constantly decrease. And if you remember from our previous vocab, a constant increase is a line. So if I have my xy axis, it's an increasing line. And constant decrease would be your decreasing line. So slope applies to graphing lines. Slope is the rate of change of a line. It doesn't matter which 2 points I pick. I have A, B, and C. The slope between A and B will be the same as B and C, will be the same as A and C. Slope is a constant rate of change. It will always remain the same. Okay, which means that the formula for slope is right here. It is exactly the same as the formula for rate of change. Now we will be dealing much more with slope because our entire unit is about graphing linears. So we're going to be using the term slope more than rate of change, but realize it is a specific type of rate of change. You will have to know how these two are related. Where rate of change can be used on any graph, and it's a snapshot of what happens between any 2 points. Slope is used only on linear graphs and will tell us what goes on over the entire graph. Now, just like rate of change, there's a couple things I know. If my line is increasing, I know that I have a positive slope. If my line is decreasing, I know I have a negative slope. And if my line is horizontal, I know that my slope is 0 because there is no increasing or decreasing. There's no rate of change. There's no change at all, which we talked about yesterday with rate of change. So there's a couple things you know. And like we talked about yesterday, the steeper the line, the bigger the slope. This line is steeper than this one, so this one has a larger slope. This one may have a slope of 3, where that one has a slope of 2. And of course, the steeper it is this way, that means the larger negative slope you have. So to wrap up, slope is a constant rate of change. It is a rate of change, but it is constant. It's going to be the same between every 2 points. It is only going to apply to our lines. We use the exact same formula. You're given 2 coordinate points, and you will subtract your y's, subtract your x's, and get your answer. And then positive is uphill, negative is downhill, and 0 is a horizontal line. Now, one thing about slope versus rate of change. When we used this rate of change formula yesterday, we divided, and then we had a decimal answer. Or maybe it was a whole number, but we divided, and we made it a simple rate. Anytime you're using this formula for slope, do not divide. Keep your answer as a fraction. And when we get into graphing, you're going to understand why. It has to remain a fraction. And of course, it will be a reduced fraction. Okay, I'm going to do one example here really quick. So if I have two coordinate points, 3, 6, and 7, 10. Now, this is my x1, y1, because 3, this is my first coordinate point. This is my second. So if I follow the formula, 10 minus 6, y minus y over x minus x. That happens to be 4 over 4, which, because I get a whole number, I can say that that's 1. Okay? If this was a 5, 10 minus 5 is 5 over 4. That cannot be reduced. So I would keep my answer as 5/4. I would not put it as a mixed number, and I would not put it as a decimal. Your homework for this section is going to be a worksheet. It's going to be the 7-2 worksheet.